All right, welcome back, folks. Hopefully, everyone had a good weekend, and we're able to get some rest and get that done. Get some of the work done. Remember, the homework for Set B chapter for this chapter is not going to be due till tomorrow. So you have some time to get it done. I'm going to go over a few more of these problems involving mole ratios. I'll review that with you in just a moment, and then I'm going to go over the first stoichiometric calculation with you involving what's called the mass to mass conversion. And then I think at that point, then you'll be able to get that homework done. But like I said, it won't be due until tomorrow. So please make sure you come by and you see me if you have any questions about it, and then we'll go over it at that point. Okay. All right. So let's go ahead and let's quickly review where we left off with on Friday, and that was with this concept of a mole ratio. Now, remember what we are doing moving forward here. What we're doing is we're taking a chemical reaction, and we're looking, and we want to obtain information about the amounts of the reactants, the amounts of the products. Okay, we want to know this because if we want to use the equation as a recipe to carry out the reaction, we need to know how much we can mix together, how much we should mix together to get the most product. Okay? And so when we deal with the stoichiometry, essentially what we're doing is we are comparing the parts of a reaction. We can compare reactant to reactant, product to product, or reactants to product. And when I say compare, what we're doing is we're trying to figure out the amounts. How much do we need? How much do we have? And from that, how much can we get? Okay? And so we can obtain information about amounts of the quantities by comparing the amounts in terms of moles. We can even do it in terms of molecules and atoms. But again, we saw that with atoms. We start out with a certain amount of atoms. We're going to end up with the same amount of atoms. Okay, so but the whole idea behind stoichiometry is that we want to be able to compare amounts, and so that means so therefore then if the amounts change, we should be able to adjust the amounts of the other parts of the reaction and be able to determine what those will be. Okay, and so that's what we're going to do in stoichiometry. And so we started out by talking about this mole ratio. Okay, this mole ratio then is a ratio, as the name implies. So this mole ratio here is a ratio. And as with all ratios, what it does is it compares two parts. Okay? Ratios always compare two parts, two different quantities, two different times, and so forth. So what we do with the mole ratio is then we take two parts of the reaction itself and we compare them. And what do we compare? We compare the amounts. And the amounts in what form? The amount in the form of the mole. Okay, how many moles? And so how do we obtain the different moles? How do we obtain the amounts of reactant? How do we obtain the amount of product? How do we determine then the moles of each one of those reactants, each one of the products that we have? Well, we need the balanced equation. Okay, and so with everything we're going to do moving forward here, folks, you always have to make sure you get the balanced equation. So I asked you to do this problem, and so go ahead, pause the video right now if you have to. Go get your work from Friday, and so I have that work. So a few of you, make sure you include your work in there. So don't forget to include your work. Okay. So and so what I would like you to do then is go get it, okay, and then come on back, unpause the video, and then let's compare your answers to the answers that we're going to get here. Okay. All right. So let's go ahead then and let's take a look at the balance equation. So you have to balance this equation first, and I think the balance equation here is though a bit trickier, but this is a combustion reaction, so hopefully most of you are able to get this. So the balance equation, that's going to be 2968. Okay, so 2968. Those are the coefficients that will balance this equation. Furthermore, those are the coefficients that we will use to determine the molar amount. That is, how many moles of each one of those reactants and products we have. So what we have here then, so make sure you remember this, what we're saying here is we have 2 moles of the propanol here, so C3H7OH. We have 9 moles of oxygen, 6 moles of carbon dioxide, and 8 moles of water. So make sure you understand what we have here. From the balance equation, we were saying that if we start out with 2 moles of propanol and we have 9 moles of oxygen to mix in with this 2 moles of propanol, we will obtain 6 moles of carbon dioxide, 8 moles of water. And that's what we learned last week, and that's what we learned at the beginning of this chapter, using the balanced equation in order to obtain the amounts of each reactant, each product in moles. Okay, all right, so make sure you have that done and make sure you're able to get that done, because we're going to use these molar amounts now, folks. Remember, we're going to use these amounts in moles in order to obtain the mole ratio. Okay, so let's go ahead then and let's derive then the mole ratios from each one of these. Okay, all right, so real quick then, let's go ahead and let me do this. I'm going to rewrite the equation here for us, okay, over this whiteboard here. Okay, so we have then 2 moles of C3H. I'm sorry, C3. Sorry, let me go and do that again. Okay. Okay, so we have then C3H7OH plus 9 O2, 9 oxygens, to produce for us 6 moles of carbon dioxide and 8 moles of water. Okay. All right. So a ratio. A ratio compares 2 parts, 2 items, 2 things. So for a mole ratio, what you're going to do then is pick 2 of these. Pick 2 of these components, 2 parts. Okay. Either you can pick the reactants product, but you're going to pick 2 of them. Okay. So for my first mole ratio, let's go and do this. I'm gonna pick the methanol here and an oxygen here, and we're going to compare it. What are we going to compare? What are we saying? We're saying then that 2 moles of C3H7OH is exactly equal to 9 moles of O2. Okay, so we're going to compare this first. We're going to compare these 2 first. Okay, so we're saying then that if we have 2 moles of C3H7OH, we need exactly 9 moles of O2 to use it all up. But based upon this right here, based upon these 2, we can set up the ratio. Okay, and the ratio then is a fraction essentially. Okay, so a fraction here, 2 moles C3H7OH over 9 moles of O2, which will be exactly the same. So we can take the reciprocal of that. Okay, so it'll be 9 moles of O2 over 2 moles of C3H7OH. Both of those ratios are equal. They don't look equal. They're the reciprocal of one another, but these 2 are equal. Why? Because this is true. So these 2 here are the mole ratios that we formed. And it's the ratio because we're comparing the amounts of this reactant to the amounts of this reactant here. So we're comparing the 2 reactants with one another. Okay, so that's 1 mole ratio. Okay, let's go ahead and let's take a look at another one. So pick 2 more parts. So we've already compared these 2. Let's go ahead and compare this to carbon dioxide. Okay, it's just arbitrary. I'm going to go ahead then and say 2 moles of C3H7OH is exactly equal to 6 moles of CO2. Okay, all right, so what does this tell us? It tells us then if we start out with 2 moles of propanol here, we will produce 6 moles of carbon dioxide. That's what this equality is telling us. And so based on this, then we can set up 2 ratios as well in order to compare these 2 here. And so let's go ahead and write out the 2 ratios there. We have 2 moles of C3H7OH over 6 moles of CO2. We can take the reciprocal of this, okay, and that's going to be 6 moles of CO2 over 2 moles of C3H7OH. Okay, and so again, they're reciprocals, but they're exactly equal to one another because they both equal 1. And the reason why they do that is because the reason why these 2 reciprocals are equal to one another, and the reason why we know that they're equal to 1 is because we know that these 2 values, those 2 amounts, are exactly equal to one another. Okay, all right, let's continue on then. So hopefully you have this. Okay, now that we've compared these 2, we've compared propanol to carbon dioxide. The last one then that we can use that propanol for is going to be propanol to water. Okay, so we have then 2 moles of C3H7OH. That's going to be equal to 8 moles of water. Okay. Again, what does this tell us? What this does then is it tells us that if we have 2 moles of propanol, we will form 8 moles of water. Okay, so let's go ahead and write out the mole ratios for these two. That's going to be 2 moles C3H7OH over 8 moles of water. We can take the reciprocal of that, so it'll be 8 moles of water over 2 moles of C3H7OH. And again, those two ratios, those two fractions are exactly equal to one another. So we have done now, what we've identified are three of the possible six different ratios here that we can make. Okay, so let's go ahead and let's set the next one. Let's identify the next mole ratio. Okay, all right. So 9 moles. So let's compare this to the products. Okay, so we have 9 moles of O2 and 6 moles of CO2. Okay. Again, what this is telling us is that if we have 9 moles of oxygen to start out with, and we're not worried about this, we will produce 6 moles. If we have 9 moles and we have enough of this propanol here, okay, we will form then 6 moles of carbon dioxide. So let's go ahead and write out the mole ratios for this then. Give me 9 moles of O2 over 6 moles of CO2. We can take the reciprocal of this, flip that around, 6 moles of CO2 over 9 moles of oxygen. And again, those two are going to be exactly equal to one another. All right, so we've determined then the amount of product that forms to 9 moles of carbon dioxide that forms to 9 moles of oxygen. What about water and oxygen? Let's go ahead and write that down. So we have 9 moles of oxygen. We will produce then exactly 8 moles of water. Okay, so we have this. Okay. And so based on that, we can write down 2 more mole ratios. We can say 9 moles of oxygen over 8 moles of water. Take the reciprocal of these two, 8 moles of water over 9 moles of oxygen. Again, those two ratios are going to be actually exactly equal to one another. So we have 5 of the 6. What do you think the last 6? So look at your paper. If you haven't got it yet, let's make sure you write this down. Okay, the last ratio then that the last one we can compare are these two here. Okay, so in each one of these here, we've taken 2 parts, 2 of the component parts of the reaction, and we basically compared them, make the ratio. Okay. So there's only 2 left that we have not compared, and that is 2 products. Okay, so let's go ahead and write that down. We have then 6 moles of carbon dioxide, CO2, and 8 moles of water. Okay, all right, so what are we saying here? That if 6 moles of carbon dioxide forms, and we had enough reactants, we had enough products, okay, we will form exactly 8 moles of carbon of water. Okay, and so based on this this equality here, we can write out 2 more mole ratios: 6 moles of carbon dioxide, 8 moles of water. Take the reciprocal of those; it'll be 8 moles of water over 6 moles of carbon dioxide. Okay, and these 2 ratios will be equal because this is equal. So make sure you understand that all of these mole ratios that we've made, they are equal. Now we've set up each one of these equalities here because we've said then that these 2 amounts are equal. If these 2 amounts were not equal, we could not say that these ratios are equal. Okay, so make sure you keep that in mind. And so make sure you write down all the mole ratios here, folks. If you did not get this yet, make sure you write down the ones that you're missing. Okay, and then we'll continue on. Okay, all right. So hopefully you got most of those. If not, then like I said, write them down. Okay, let's move forward then, and let's take a look at what happens. Okay, So in that previous example, we saw them, if we start out with a certain amount that is established in the balance equation itself, we're going to get the amount that we talked about. Okay. All right. So what if you don't have those molar amounts that you obtain from what we call the stoichiometric quantities? Okay. Which means that what if you don't start out with the molar amounts that are given to us in the balance equation? Okay. What can we do then? Well, let's go ahead and let's take a look at our problem like this here. Okay, so let's take a look at this problem here. They're asking us then to use the mole ratios to determine then the moles that form, how many moles that form from ammonia if you start out with 6 moles of nitrogen. Okay? Well, first of all, what you need to make sure you do is let's go ahead and identify the reaction. Okay? And so the reaction here, and so remember, with all these calculations, you always want to start out balanced equation. Okay? So they asked us then about the formation of ammonia. Okay? So let's go ahead and write that down first. Okay, so we have then N2 as a gas plus H2 as a gas, and we've done this before. Okay, as a gas. So I'm going to use it again. Okay, so we have then 3, 2, 2. I'm sorry, 3, 1, 3, 2. Okay. And okay, and so with that said, then what we are given here, and I just want to quickly ask you to do this. Okay, write down the mole ratios that we need that you can obtain from this particular equation. Okay, so real quick on your paper, I'm gonna pause the video right now for you. I want you to write out the mole ratios that we can get from this balance equation, because we're going to use it in order to solve this problem. Okay, so go ahead, take about 2 minutes, write out the mole ratios for this reaction. Okay. All right. So I'm not going to go through all the analysis that we went through in the previous problem. Let's just go write out the mole ratio. Okay, so comparing the first nitrogen to hydrogen. Okay, so we have then 1 mole of nitrogen, okay, for 3 moles of hydrogen. Again, these numbers here come from the balance equation. Okay, and so we can flip that around. We have then 3 moles of hydrogen over 1 mole of nitrogen. Okay, so that's one mole ratio that we can come up with. What about nitrogen to ammonia? Okay, so let's go ahead and do that one. 1 mole of nitrogen, okay, 2 moles of ammonia, and that's going to be equal to, take the reciprocal of this, 2 moles of NH3, 1 mole of nitrogen. Right. So hopefully the last one, there should be 3. Hopefully you got the last one, hydrogen to ammonia. So we've compared nitrogen to hydrogen, nitrogen to ammonia. The last one then is going to be hydrogen to ammonia. Okay, so let's go ahead and write that down. We have the 3 moles of hydrogen, 2 moles of ammonia. Okay, and the second ratio from that one, 2 moles of ammonia. Oops, sorry. Okay, and 3 moles of hydrogen. Okay, so those are the 3 different mole ratios that we can come up with. Okay, so from the balance equation. So let's go ahead and look at what they've given us. Okay, so they're asking us to compare. Let's go ahead and write this down. They're asking us then they're asking us then if we have 0.6 moles of nitrogen. Okay, so if we have 0.6, not 0.06. Sorry. They're asking us if we have 0.6 moles of nitrogen. So this is the conversion now. So these problems are essentially conversion problems, folks, because they're asking us if we start out with 0.6 moles of nitrogen, okay, how much ammonia will be produced. Does this ring a bell to you, folks? And it should, because this is a conversion problem. So they're saying that if you have 0.6 moles of nitrogen and only 0.6 moles, so remember from the balance equation, what we're told here is that we have 1 mole of nitrogen. So they're saying that let's say you have less. Let's say you only have 0.6. How much of the ammonia do you expect to form? Now remember, from the ratio here, from this ratio here, we're saying then that if we had 1 mole of nitrogen, we should expect to form 2 moles of ammonia. Okay. So in this particular conversion, then what we're doing then is we're saying that if we have less than 1 mole of nitrogen, how much ammonia will be formed? So that is our conversion. Folks, moving forward, all these problems, and I'm running low on time, all these problems are conversion problems that we're going to do. So let's set it up as a conversion problem here, okay? So let's go ahead and set it up. We have then 0.6, okay? So we have 0.6, okay? So we start out with 0.6 moles of nitrogen, and we want to convert that into moles of ammonia, okay? We have what we start out with. We've identified what we're solving for. What is our conversion factor going to be? Now remember, our conversion factor has to have both this unit and this unit here. So we have to identify one of these three here. And again, we have our conversion factors here, folks. Which one of these 6 here will we use to convert between moles of nitrogen and moles of ammonia? Well, looking at the first one, we have nitrogen, but we have hydrogen. So we don't have ammonia in this one. So we're not going to use any of those, okay? Looking at the last one, okay, we have ammonia, but that's being compared to hydrogen, okay? So we don't have nitrogen in that one, so we won't use that one. It's this one here that we're going to use. So the question then is, will we use the first ratio or will we use the second one? Which one will we plug in to use, okay? Well, we start out with nitrogen. We want to end up with ammonia, and so we want to use the particular ratio that will allow us to cancel out nitrogen and to get ammonia, and this is the one we have, okay? So and I'm sorry, plugging it in then, let's go ahead and plug it in. We have 2 moles of ammonia, okay, and 1 mole of nitrogen, okay, so plugging that in, we get our answer then as being 1.2 moles of ammonia, and that's our answer, okay. These are conversion problems, folks. These are conversion problems that you'll have to be able to do. So let's go ahead, and what I'd like you to do is then, I'm running low on time here. So to finish out the period, what I'd like you to do then is let's take a look at number 17 here in your problem set. I want you to finish up this problem here, okay? And then I want you to work on this. And just like what we did on Friday, what I'll do then is I'll start out with this problem on Tuesday, tomorrow. But I'd like you to work on it today. I want you to work on it. You used the previous problem. I modeled how to work out these problems through. If you need to, write out all the mole ratios. It'll give you practice with that as well, okay? So write out the mole ratios, okay, from this equation, and then go ahead and do the calculation, okay? So go ahead and get that done. Use the previous slide and use what we talked about with the previous slide to help you with this problem here. And then we'll pick up and then write it out on your paper, submit it submit it at the end of the period, and then I'll take this problem and I'll work it out for you tomorrow. Have your work available so you can compare, but I'd like you to finish this up on your own, okay? And then we'll pick up this problem tomorrow, okay? All right, very good, folks. So I will see you tomorrow. Stop by if you want to stop by after school today, get some help with this, or if you have any questions, okay? All right, folks, if not, I will see you tomorrow.